What are gravitational waves and how are they formed? Let's see the answer of these questions in this video. But before that, please do subscribe my channel and please like and share this video also. So before understanding gravitational waves, you should know what is meant by space-time. Note, I did not say space and time. When we refer to space and time, then in that case, we are referring to space and time as different entities. But Einstein proved in 1905 using his special theory of relativity, a paper which was published in 1905, if you all know. In that he stated that space and time are not different entities, but are same entities, right? Which he named as space-time. So what is its significance? Well, let's see. So if I talk in reference to a special theory of relativity, in that Einstein stated that when an object moves close to the speed of light, then it starts to move slowly in time but more towards the space. And what does it mean? It means that time slows for that object with respect to an observer which is at rest, right? Of course, this is something mind-blowing. I won't discuss it right now. If you all know, then it's good. If you all don't know, I will make a video soon, right? But if we consider Newtonian mechanics, in that it was stated that space and time are different entities, which means that there is no limit to the speed of any object in the universe. And the second thing was that, and it implied that all the events are simultaneous, which is wrong as per special theory of relativity. Well, of course, I know that this is very much confusing, so I won't discuss much upon it. If you know it, then it's good, else I will make a video on space and time and space-time in the coming future. So now let's come to general theory of relativity. In that, Sir Albert Einstein stated that gravitation is basically the bending or the curvature of the space-time, which is due to the presence of a mass or energy. Earlier, we used to consider that only the masses can produce gravitational forces, right? But Sir Albert Einstein told that the necessary condition for the gravitation is not mass, but it is the momentum and the energy of a particle, which means that photons can also be attracted, and which was something against the Newtonian mechanics. Why? Because we all have learned the formula F is equal to G m1 m2 by r square. So if you have any mass and there is a photon, then it means that the mass of photon is zero. We know it. So it means that force of attraction should be zero, right? But Sir Albert Einstein said that this is wrong. Sir Albert Einstein stated that we don't need the masses of the bodies, we need the energy and momentum. So of course a photon has momentum and energy both, right? So in a short form, if I say, basically gravitation is the curvature of space-time, right? It is similar to having a blanket or a membrane and putting a very massive object at its center and then observing the curvature of the blanket. It is similar to that. And if you put any other mass near its affinity, then of course it will start to revolve around that mass and eventually fall inside that. Similar is the case with the gravitation. Space-time is like a membrane or a blanket in which gravitation is due to the curvature of space-time. So this is the basic idea of gravitation using general theory of relativity, and now we are going to understand what is gravitational waves. So gravitational waves are basically the fluctuations or ripples produced in this space-time fabric, right? So how are these gravitational waves formed? Well, suppose you have two very massive black holes which are colliding with each other, then due to their collision there will be lots of fluctuations and ripple formation in the space-time fabric, due to which gravitational waves will form. So now the question arises that what is the speed of these waves? Well, these waves travel at the speed of light. So this is the basic idea of gravitational waves, and I hope it is clear now. If it is clear, then please do like, share, subscribe my channel, and please support this video. Bye bye. Take care.